Hello friends, I am Dr. Swati Gauri and today we are going to see Carnot's cycle. So in my talk I am going to explain first construction of Carnot cycle and then its PV diagram. Carnot's heat engine is the first engine given by Saudi Carnot. Now what do you mean by heat engine? Heat engine is any device which can convert amount of heat into mechanical work. So Carnot engine is capable of converting heat into mechanical work. Carnot engine is basically an ideal or theoretical reversible internal combustion four-stroke engine. Internal combustion means the fuel get burned inside the engine itself, therefore it is called internal combustion. At the end of each cycle or each PV cycle, we retrace the original state, therefore it is called reversible. As it is an ideal engine, therefore it has maximum possible efficiency. There are four major parts of the Carnot engine: cylinder, source, insulating stand and sink. Cylinder consists of a weightless, frictionless, movable piston and working substance is kept inside the cylinder. Except the base of the cylinder, all the sides of the cylinder and walls of the piston are made up of non-conducting material so as to avoid heat losses. Source. It is also called hot reservoir. It has capacity to supply amount of heat Q1 to the working substance at constant temperature T1. Insulating stand is the part where engine can take rest. Insulating stand is made up of non-conducting material and all of its sides are non-conducting. Sink. It is the part where unwanted amount of heat is rejected at constant temperature T2. Sink is also called low reservoir. Temperature of sink is less than temperature of source. There are four operations in the Carnot cycle: isothermal expansion, adiabatic expansion, isothermal compression and adiabatic compression. Now let us see them one by one in detail. Initially, isothermal expansion. As seen in the diagram, you can see a graph P versus V. This graph is called PV cycle or PV diagram or indicator diagram. As I have told you, there are four operations. So, in this graph also you can see four operations: AB, BC, CD and DA. Now let us see the first operation, that is isothermal expansion. Initially, the cylinder is kept on hot reservoir or source. Source supplies amount of heat Q1 to the working substance. Due to the absorption of amount of heat, the working substance, its volume goes on increasing. The working substance expands and therefore the piston moves in upward direction. This is shown by the upward arrow. Here the expansion is done at constant temperature T1 or isothermally, therefore the name isothermal expansion. For 1 mole of a gas, the work done is given by 2.303 RT1 log of final volume upon initial volume. So in this operation, final volume is VB and initial volume is VA. So we can write work done as 2.303 RT1 log VB upon VA. Now second operation, that is adiabatic expansion. The working substance is kept on the insulating stand. Working substance has tendency to expand, so the expansion of working substance still continues. Volume of the working substance still increases. But in this process, for expansion, amount of heat is not supplied. Therefore, the working substance uses its own internal energy to expand, and therefore internal energy of working substance decreases and hence temperature of working substance also decreases. Therefore, temperature decreases from T1 to T2. During this expansion, piston is still thrown in the upward direction. This expansion is called adiabatic expansion because amount of heat is neither rejected nor absorbed. Work done in this operation is given by R T1 minus T2 upon gamma minus 1. As you know, R is gas constant and gamma is ratio of principal specific heats, which is constant for the given fuel. This operation is shown by the curve BC. Now let us move to the third operation, that is isothermal compression. Working substance is now kept on the cold reservoir or sink. The piston moves inside. Working substance amount of heat is rejected to the sink. Q2 is the amount of heat rejected at constant temperature T2. As piston moves inside, therefore, the working substance gets compressed. Its volume decreases. During this compression, temperature remains constant and therefore it is called isothermal compression. Work done is given by 2.303 RT2 log VD upon Vc. As amount of heat Q2 is rejected, therefore arrow is shown in outward direction and the operation is shown by the curve CD. During the fourth stroke or fourth operation, that is adiabatic compression, the working substance is again kept on the insulating stand. Working substance has tendency to compress, so the compression still continues. But during this compression, amount of heat is not rejected and hence the internal energy of working substance increases and therefore temperature of working substance also increases from T2 to T1. Amount of heat is not exchanged during this compression, therefore it is called adiabatic compression. Work done is given by minus R T1 minus T2 upon gamma minus 1 and this operation is shown by the curve dA. Thus, at the end of this baby cycle, we reach the initial point A again. That is, this is reversible cycle. Thank you.